So hi, I'm Jaime Rodriguez, again, Windows 8 Technical Evangelist, and I'm going to spend the next 45 to 50 minutes talking about hardware and integrating with hardware from Windows Store apps. So that's kind of what we're going to cover. One thing, the takeaway, because I'm going to cover everything fairly fast, the takeaway I do want you to walk away with is Windows 8 will provide seamless access to hardware, whether that's webcam, microphone, sensors, NFC, touch. Right, we have a very nice platform that seamlessly integrates with hardware. You're going to see a little bit of that, but I'm going to go very fast. So again, I'm going to try to hold questions a little bit to the end of each section, and then if you want to dive deeper into specific areas, then let me know. And before I get into it, I wanted to start with webcam, but I know that we didn't give you a lot of information on video playback, so I'm going to give you 2 or 3 slides on video playback before we dive into the hardware component, which is the webcam. And we've been talking about SAML C#. So the way you play video and audio, the highest level to play video and audio with SAML and C# is using the media element control. And the media element is one control that you would drop into your SAML, and you will use that for all your playback. We can do everything that you would expect, like all the events for sync, volume change, download, markers. Media open, failed, ended, all that stuff, all the events that you would expect are there. Same thing for methods, right? You can play, pause, stop, so you can write your controls, and actually do all the right things so that you can build a custom experience. If you don't want to build a custom experience, we have plenty of samples. We have something called Media Player Framework that gives you a very rich, very great looking, already built video playback experience that you can use. You just drag it and drop it into your application, and you get transport controls, you get full screen. It's got a lot of functionality, like support for ads, support for all kinds of stuff, like closed captioning. Everything that you would expect is there. It's a higher level control than this one. It's open source. It's up on Codeplex, and it's called Media Player Framework. But the lower level media element will probably do most of the needs that you have if you want to create your own experience anyway. So one thing that I want to highlight for this, one of the properties here that's interesting is the audio category. If you want to play audio on the background, which we've been talking about it in a few of the sessions, if you want to play back on the or audio on the background, there's this extra property here on the media element that's the audio category. And you have to set that to be background capable media. You still have to go back and declare it in your manifest like we showed you earlier, but you have to set it here, and that way you'll play on the background. So if you're familiar with Windows, in fact, let's start with this slide and then we'll go back. With regards to formats and codecs, the stuff that you would expect, right? MP4, H.264, or VC1 video is what we play by default. If you're looking at video. If you're looking at audio, we have AAC, MP3, WMA. And then if your application has a different format or a different codec, you can actually bring in, just ship your plugins on your own and have all kinds of different functionality. For example, adaptive streaming, right? Like something like what Netflix uses. Somebody asked yesterday about HLS. If you want to do HLS, you can just bring in the component that does HLS from within your app, and you can ship all of that and include it as part of our media pipeline. We'll seamlessly integrate with that. So with regards to video, the basics are there. What everybody has is there. We also have a little bit of extra functionality that might be worth highlighting. DRM, so digital rights management, for copy or for content protection. We use PlayReady. That's the Microsoft standard. It's actually very common across the industry, very popular. So it's used a lot, and a lot of people have it. So for DRM, if you need it, we use PlayReady. Some of the new features that we have are, for example, 3D video. So you can actually play 3D video on Windows 8 if you wanted. We have a lot of extensibility in audio and video effects, a very, very rich pipeline. Very comparable, actually, or definitely comparable to what you're getting out of iOS, even if you go at the lower levels. And I'll have a mapping in a minute that might help you guide you through it. You've obviously heard us talk about background audio a lot. One of the things that we have is we have Play To, which is a contract that we can use to play onto TVs and other DLNA devices. So this is our equivalent of AirPlay. It's called Play To, and it's standards-based stuff. It's not something where you have to, like you can play to any TV that supports the standard, as opposed to playing to an Apple TV or something that might be a little bit proprietary, right? So that's kind of where we're at with regards to just video playback. I did a kind of high-level mapping. I didn't want to map every single thing, but the 3 or 4 that you would expect to see, again, AirPlay and Play to are kind of, that's our mapping as we have it. It's not the same thing, so you cannot use Play to and Play to, and Play to an AirPlay device, but you can use Play to and Play to TVs that support the standards that we would use. If you're looking for example, MP movie player controller, that's where media playing comes in. If you're looking for music player controller, that's where media element would also come in. If you're using background audio, we do have the media control. Somebody asked earlier, hey, what happens if I have a background audio, my app gets suspended, I'm supposed to be in the foreground because I need to handle the control like play, stop, all that stuff. We give you media control for that. So when your application gets, when your application goes onto the background, you will have media control, or we will have media control. You'll subscribe to those events, and then we'll call you back if the user wants you to pause or do anything with the audio that you're playing, right? For those that are doing like kind of high level or low level, advanced, for example, audio manipulation, if you're looking at OpenAL or AV Foundation, which is what most people use for lower level audio manipulation, on the Microsoft world, you'll have equivalent functionality, and it comes out of either the WASAPI, as we call it, which is the WS API, or X Audio. So you should look for those in our libraries and in our documentation, and you'll find the equivalent functionality. And then in iOS, you kind of have the MP Media Library, which I think, it gives you access to Media Library, and it does a little bit more, other types of content, and it actually, books and stuff like that. On our world, we pretty much have a Media Library, which is the folder that you're familiar with where we put media, and you can crawl through that, right? So we have kind of our pictures library and our video library there. But its file system is not the exact same than MP Media Library, but that's as close as we're going to get. The one thing I highlighted there, we don't have MIDI support on Windows Store apps. So if you're writing an application in iOS that uses MIDI, you would end up writing a Windows 8 application, not a Windows Store application. That still works great on Windows 8, but we don't have the APIs on Windows Store. So that's high level for video. Let's get into camera, because this is all about hardware. And here I kind of have, I started with giving you kind of the namespace and the kind of capabilities that you're going to get out of our Windows Media namespace. And most of these are already covered, but the one that's interesting is capture, right? We haven't covered capture yet. So if you're looking at capture, there's 2 options for you to capture photos and video using the webcam, right? The first one is the camera capture UI. And this is a standard UI. It's kind of like, I call it it's the equivalent of a system dialog, right? It's the standard camera capture UI that you're going to get across all applications, right? If you go into, for example, the camera app, I tested it earlier. So you see here, this is a very standard dialog. Like here, this is one line of code, right? On your application, on your SAML, you just said, hey, camera capture UI, get photo, and we give you everything else. So this, for example, the camera options here, switching across the quality, and switching across the formats, and switching across Microsoft, video stabilization, all these things, and these are extensible. So depending on the type of camera that you have, you might see more options here, and the system's taking care of all of that, right? So if you just want a simple picture like that, you just click on it, and you'll be okay, right? You can also do videos. So this is kind of the system UI as you would get it from Camera Capture UI. If you want to create a custom experience where maybe you want to just show how, you want to show it's the camera and have something on the side or everything like that. So you just want access to the stream that the camera is getting. For that, you actually use the Media Capture API. So we give you Media Capture API, and then we give you that stream, and you can play it back on the UI in something smaller, some custom UI that you would have. And you would actually be able to save it, encode it, and do everything else. We give you APIs for all of that. I just showed you this demo a minute ago, so we're okay. Before you access camera, or if your application is going to access camera or microphone, we do have capabilities for these. So you will have to go in there and edit or declare the capabilities when you ship your application. And here's an example, as I showed you earlier, of just capturing the camera. So the one line, if you're looking at here, most of these are settings. So I have Camera Capture UI, and then I just go dialog, capture file async, and I tell it to do a photo. The rest of it here is just like telling it, hey, 16:9, cropped aspect ratio, and then here's the photo. I'm actually displaying the photo on the UI here. So the rest right here is the bitmap image that I'm showing on UI. So the one-liner that you would need is camera or capture file async. And you would use the exact same thing if you wanted to record video. We just, you just change the format and pass the format as video, and you tell us what format you want, and then we'll go ahead and do the exact same thing. So with regards to camera, we give you the exact same access. Here's kind of for you a reference where you can say, hey, what can I do with either one? Again, the difference to me is camera capture is very generic UI. So the user will be familiar, they'll be able to use it, but it's a little bit more limited. And then media capture, it's something where you control everything, you control every pixel, you create your own experience, and then you just gotta adhere to one of the supported formats or write the plugins to do more with the formats that that we wouldn't handle automatically. Right, and it's not direct mappings, but if I was to give you hey, here's kind of the way I think about it. I think of camera capture more as the equivalent of image picker controller, right? Even though there you can customize a little bit more. And then I would think of media capture as what I would use if I was using AV capture APIs, lower level stuff on the iOS world today. So that's what we have in camera. It's very straightforward. Is there any questions around it? Nope. Good. So moving on to sensors to give you other capabilities that we have within the hardware. And the first one is geolocation. And so we have access to geolocation. We actually do on the Windows Store platform. We do location not only hardware GPS based. So for example, right now I'm using this Lenovo system which doesn't have a GPS, but our location system can actually go in and say, look, based on the Wi-Fi triangulation and based on what we know about your IP address and all this stuff, we can try to give you a location out of that. Obviously, that's not as accurate as GPS, but when you're dealing with our geolocation platform, you're actually getting all of that, and obviously we'll give you the more accurate data that we have. So if there's GPS on the system, you're going to get that. If there isn't, then you're going to get Wi-Fi triangulation or any other IP address or some other thing provided by the Windows location system. So that's just where we're at. With regards to using the API, I'm going to give you a couple examples because this is very straightforward stuff. It's kind of boring, easy stuff. So you just declare a geolocator. And if you just want to get a location one time, so you just want to see, hey, is this user in the city or whatever, so that I can give them restaurants or anything like that, I can just call that get geoposition async, and just call it once, and that will be done. And it'll come back, and I'll have my results and everything else. If I want something that's continuous, that's actually changing as I go and kind of following the user, then I would use the position change event. And you see here like the results that come back from position change, which is everything that you would expect. You get a position with coordinate, with latitude and longitude. You get accuracy, right? And you can use that to manipulate. And this will be called obviously as many times. You can say the accuracy. You can set some parameters on the location platform such that you don't get called back too often, or you get called back enough. So you can change a little bit of that, and then just use your parameters here. Something to notice, you do have the geolocation APIs are coming back on a background thread. So yesterday we talked about, hey, you can only access UI elements and all the UI from a foreground thread or from the main UI thread. So you see here I have a dispatcher, and this is actually old code. This should be dispatcher run async, and that's how I dispatch back to the to UI thread so that I can update this text block and everything else. So that's just kind of what location would do. Very, very straightforward stuff with regards to location. If you're an HTML5 developer, we do have support for the HTML5 standards location APIs. So you can use the geolocation that I just showed you from HTML, which is the exact same API. It's a WinRT API that you can access, or you can get the HTML5 APIs. And both of them will give you the exact same result. It's one underlying platform just exposed via two different APIs. Did you have a question? Is there compass support? I'm getting to it's coming next, sorry. That's a different sensor than location for me. So with regards to sensors and different types of sensors, here's kind of how I think about it. or how we think about it from the Microsoft world. So we obviously it comes down to the hardware you have available. But I always say, look, we have we have kind of 3 levels of data that we can give you through our APIs. The first one is simple data, like hey, you do have rotation, or you have an accelerometer on your machine, and you just want to know when they turn landscape or portrait, right? That's what I call the simple data, right? And the system is doing that for all your applications already. You don't have to subscribe. You don't have to do anything to get that kind of information. Now, when you're trying to get into sensor data, or what I call raw sensor data, you do have to subscribe. And by default, the type of devices that you would think of would be a light sensor or accelerometer or gyro, right? Does it kind of like, that's what the hardware is shipping with, right? And then what Microsoft has is we have a platform that we call Sensor Fusion. This is stuff that came out of Microsoft research, and it takes input from several different areas. I'll show you a slide in a minute. It takes input from several different sensors, and then makes up of the data. So wait a minute on Fusion, and you see the slide. Let me first show you the pattern that we use for all of our sensors. So I'm only going to show you one code snippet because this is the exact same pattern that we use for all of our sensors. So first of all, our sensors are always singleton, so you can just go back and say, hey, Windows devices.sensors, and then from there you can use gyro or whatever you're after. In this case, I put accelerometer. And then you say get default, and that'll give you the singleton for the system that you're interacting with. And then from there you can just subscribe and say, hey, call me when the reading changed. All of them have the exact same property, the same event. It's called reading changed. And then when the reading changes, you can come back here and say, oh, just read whatever your actual result needs to be, right? If this was not accelerometer, if it was gyro and you wanted to do yaw or something, the right parameters for gyro, you would just get different parameters here on the result, but it would be the exact same pattern. You're subscribing to reading change, and then you're just getting the events called back, and you're handling them on your own. So this is just for accelerometers. So I have acceleration X, Y, and Z that I'm passing back, but it's the exact same pattern, right? Now that's for the simple sensors. The next one that we do is sensor fusion, right? Which for us is the process of taking multiple sensor inputs and then synthesizing them, right? This is stuff that came out of Microsoft research like 2 years ago or so. Windows Phone 7.5 was the first one to ship from Microsoft. Windows Phone 7.5 was the first one to ship Fusion. So we had some pretty innovative stuff there. And here's kind of how it works for us. And this is already now, everything here is on Windows. So think about it from a pure, I have an accelerometer, a gyro, and if I'm just going to do pass-through, then that's what you're getting. That's the raw data as you're seeing, as you're familiar with. And then if you add, for example, magnetometer, you can actually do the exact same where you can pass, you can get data. But things get more interesting, and usually when you tend to have that, you tend to have when you have a magnetometer, you tend to have the 3 of them together because that's, hardware that's a little bit more specialized or dedicated. And what we do there is we pass this through this thing called sensor fusion. And this is just a software algorithm. There's nothing hardware related. When it comes to the sensor fusion, it's just software algorithms that are doing magic with regards to the data. And then from the sensor fusion, what we do is, from there, we can give you data that say, hey, here's what the inclinometer or compass, or here's what highest level, more accurate device orientation would look like, right? So we just give you the results from that. It looks to you like Compass API, but there doesn't have to be, it doesn't have to be a physical one. We just give you the results that look like the right ones. If you have, like, for example, like 2 out of 3 where, like, for example, you have an accelerometer and a gyro, but you don't have a magnetometer, sensor fusion will still work, right? But the results are a little bit less accurate, so you just do the best that you can with regards to the hardware. And the APIs for these look exactly the same that what I showed you earlier, the reading change event, and then you just process your data as you go. And you can tell it, you can configure it a little bit with regards to how you capture stuff. So that's pretty much it when it comes to sensors. It's pretty much my recap is that it's very easy for you to actually just integrate with sensors. What you would expect from any platform, you will have the right parameters, and you'll have very simple APIs that you would expect. Those stuff is very straightforward, and sensor fusion just opens up some new possibilities, some certain new scenarios, types of games and stuff like that. You can do something cool if you have that kind of higher level data. Go ahead.
When the results from sensor fusion are less accurate because you only have 2 out of 3 of the sensors, so it what the accuracy is?
Yes, all of our sensors have accuracy. And so the question is, hey, if the results are coming, from sensor fusion are coming and they're less accurate because maybe I have 2 out of 3, or even, for example, for location, right? We always give you accuracy back. So we give you something that tells you, hey, here's what we're looking at. So for example, with location, if it was Wi-Fi, we would tell you, oh, this is probably within a 3-mile radius or whatever, as opposed to, hey, this is GPS, which we're talking 100 meters or something like that. So we do that for all the sensors.
And then on that note as well, is there a way for you to specify what accuracy you do want? So optimize don't get so much accuracy.
Yep. So the question is there ways to configure accuracy so that you don't get called back too often or stuff like that? That one comes down to each sensor. So the short answer is yes, there is ways. But like for example, location, I've used it. I've actually never used it on gyro. So each one of those sensors will have their own properties that you can go back and configure. So the answer is yes, but you have to look at the API and make sure that you're looking for what you're looking for is there. So go ahead.
What would be like without a question or two? On geolocation and sensitive stuff, is there any guidelines in terms of battery usage for mobile devices?
On geolocations and sensors, is there guidelines or guidance on battery usage for mobile devices? So
Apple is telling you don't get more accurate than you need to, and they try and use Wi-Fi persisting versus the actual GPS.
Yep. So we do have guidance on our website. So if you go to the Developer Center, there is some high-level guidance. I think it's the exact same for everybody. Like, don't pull more than you have to. Don't get more accurate than you have to. The one thing that I would tell you, and I think every platform does this too anyway, is obviously Microsoft is also keeping an eye on all those things. And we know, we have very specific algorithms in the systems that go back and look at how are we doing on battery and certain things. So in some cases, Windows adapts itself to where you're at and where you're coming out on battery. So on that side, we have a little bit adaptable. But we do have something on the website, on the Developer Center, that talks about it. And very much like I've read the Higgs for one, platform, and I kind of I read the other ones, and I'm like, it's 80% the same. It's going to be very similar to that. So if you're on mobile, you already have a lot of the guidelines, a lot of the knowledge. Anything on sensors? Go ahead. Yep. So let me make sure I understand the question. So some Windows, like most Windows devices, come with sensors already. Or you're saying some Windows devices come with sensors, and you're saying does Fusion will Fusion work with those devices? Yes, the Fusion API is fully available on Windows 8. So for example, and this is not my device because I'm using a different one today, but I have an Intel laptop that has every possible sensor. It's kind of a prototype, developer prototype that they released, and I can use that, and I can rotate it, and it's not something I would do all the time, but I can definitely get all the data for any of the sensors. For some more tablets, every one of them has slightly different hardware, but yeah, the Fusion APIs will work pending what hardware you have available. Go ahead. So the question, I'll repeat the question, but I don't know the answer. The question is, hey, laptops are bigger, clunkier. It would, if the OEMs that are manufacturing the laptop are they taking care of that and making sure that the APIs and what the APIs report, is kind of optimized for the bigger form factor, right? Is that? Yeah. So it's still the same question. Is it more sensitive or less sensitive? And the answer is I don't know. Hardware is I can't even change a light bulb. So with regards to hardware, I would have to ask some of the OEMs, and it will be specific to each device. So let me take a couple of questions from the Twitter stream, and then we'll continue going. Can you create a media element programmatically instead of referring to it from SAML? Of course. Anything that you can do from SAML, you can do from C# code, or C++ code, or VB code, everything. So SAML is nothing but a serialization language. Very much, I don't want to get into the very much like SIB, but it's nothing but a serialization and initialization language. So yes, anything that you can do from SAML, you can do from code. For augmented reality apps, some GPU, CPU vendors like NVIDIA and Qualcomm are providing SDK and libs that provide hardware acceleration on Android. Is Microsoft working with vendors to provide similar capabilities for Windows 8 devices? Yes, we are working with vendors all the time, so we work with them on drivers, we certify their drivers. So I would not expect that you'll see a lot of extra SDKs because with Microsoft, we are dealing with them directly. The drivers ship through Windows Update and all the other stuff. So you might not see it as SDKs, but we're definitely working with the vendors like NVIDIA, Intel, Qualcomm, or all of the vendors that would have hardware. We're always working on them. I was thinking Qualcomm from my phone days. And then last question that I'll take from the Twitter stream so I can move to touch. Can I develop a location-based application in the WinRT version of the Surface tablet? So can I develop a Windows location-based application in Windows RT? Of course. Exact same API that in using x86 is going to work in Windows RT. So nothing different there. Everything will be there as long as you have location or you're willing to live with the location that we go. There's not hardware-based, you'll be fine. You'll have the exact same thing. Let me move on to touch because that's the last piece that we have on hardware. You've seen it for the last 2 days. We are very, very touch-centric. We always, from Microsoft standpoint, say we are a touch-first OS. Now, in parallel, we also tell you, don't forget about mouse and keyboard because there's a lot of users with mouse and keyboards. So let me tell you what we did, or after these slides, I'll tell you what we did with regards to trying to deal with mouse and keyboard. So the first thing is you saw Aaron talk about our touch language or our touch interactions. We have some very specific gestures that are going to be across the system, and you'll get familiar with them as you go. And your users are going to be very familiar with them. So tablet users, use them a lot. A lot of people say, "Oh, it's not intuitive," and 3 days of using it, like my kids can go in and out of the app bar, can switch across apps, very, very quickly. It's very easy for people to get used to it after 3 to 4 days of using it. With regards to touch and how we thought about this a lot before because we knew it was going to be a significant change, and we knew we had all these devices out there, and we knew we will continue to have devices with a mouse and high precision interfaces. So here's what we did. We said, look, we have to come up with this new platform, right? But we're not going to walk away from touch and pen, right? So what we did is we said, hey, let's just unify all input on our platform such that whether you're using touch or mouse or pen doesn't really matter, right? So that's what we've done on Windows 8. Right? So whether you're using touch or mouse or, and you've seen it before in all my demos, like earlier I handled a landmark tapped, right? And the event says tap, but I was using the mouse and I click on it and that's the exact same thing in a tap, right? So we can actually go back and say, look, you can just, we unify the platform such that, it doesn't matter where you're looking. You can code to one API and then you'll be okay. And if I was to tell you to code for one API, the one advice that I would tell you is code for touch. And the reason I say code for touch is because I run into UIs a lot where everything's too little to touch, right? I never ran into a UI where a big button is hard to click on, right? But you definitely run into UIs. If you look at the desktop, right, on Windows, you see things that are like, oh, I got to go click on the right corner, right? And that's harder to do if you're using your finger. But if you code for touch, then that's a common denominator where any API, you're going to get all input. Your users are going to be fine because they'll be effective with either pen or mouse, right? And so you code for touch and you'll get mouse and pen for free. With regards to kind of like the way I see it in terms of layers for building touch support into your app, here's kind of how I see it. First of all, when you write your app, you can just use our standard controls like list view, app bar, all of these controls, and they're going to handle all of the touch for you, right? So when I draw, you've seen me before. Every time I've done grid views on the last 2 days, all the touch panning and everything else is handled automatically, right? So if you don't ever worry about touch, you still probably end up with a decent app as long as you're using a lot of the standard controls. Then the next level of support that you have is just scrolling and zooming. And that's just you handling scrolling and zooming events on certain controls if that's what you want. And then after that, we have 3 layers of events, and I'm going to show you a little bit of those in a minute. We have pointer events, gesture events, and gesture recognizer. As you're coming down the slide here, the farther down you go, that's the more code you're going to write, right? And the more precision and control you're going to get. So for example, like when you're getting down to gesture recognizer, you're writing a C++ gesture recognizer at the lowest level of WinRT, and you're getting full-blown control where you can do custom gestures and everything else you want. So we just give you the 5 layers, but very few people need to go down. In fact, pointer is usually a good place for you to kind of stop. And gestures is definitely it's also a good place for most people to stop. Very few people need to write their own gesture recognizer. So pointer is the API that unifies all of our devices into a single system, right? So we can just go in there and say, hey, code to the pointer API, and you're going to get pen and touch and and mouse for free. So we have the dumb pointers or our pointer APIs. Just follow very similar patterns that you would get. This is dumb because it's an HTML, or it's referring to HTML, but all of our SAML and UI elements actually support all the pointer APIs, and it's all at the UI element level. So every control is going to have support for all of this stuff. The typical APIs that you're looking at, and if you're familiar with our mouse APIs, you'll see that they're very, very similar. So we have pointer press, release, moved, enter, exited. Right, you could replace, that pointer word with mouse, and you would see our mouse events from, the previous years. So that's where we're at. So the pointer events is where it's going to happen, and they're all going to be at every UI element. So all your controls, all your UI is automatically going to have support to some of these. Let me show you this demo. This demo comes with the SDK, and I'll just show you where we're at. And I'll show you. So let me show you the code. This is already written because it's more than 10 lines of code, which. But this is just an empty canvas. There's some UI on top of it, but the interesting scenario here is this empty canvas right here. And you'll see here, it's just a canvas, so it's just a surface that I'm going to listen for events for. And you see here that all I'm doing is subscribing to all the pointer events. So pointer press, release, move, enter. And these are only pointer events. You can see here through the code, I don't have a single mouse or touch API. All I'm doing is subscribing to all the pointer events. Right? And this is going to have a little bit of a paint application. And then you see here that if you look at the handlers, all I'm doing is whenever I handle it, I'm just drawing lines or drawing a point, so that it looks to you like you're drawing with regards to your APIs. So I'm just going to go back there and just say start debugging. And the reason this exercise is useful is because, so first of all, I'm going to put my finger on the screen, and I'll drag it around, and you can see that it's following, like you can see the touch right there where it's follow my finger, and that's me using the finger. Now, you saw me that I only use the pointer API, so now I can come back here, and you see that it's a different cursor when I use my mouse, but it's following everything the exact same way, right? All I did was use the pointer APIs, and then the very last one is if I have my pen, right, I can just go in there, and with the pen I can do a lot more. I can add my name and everything else, and you see there, and it's all just doing the same pointer API, the same events that you do. So that's the unification that we've done with regards to the pointer API. And I think that's going to simplify your world quite a bit with regards to writing applications and not having to worry about, what about mouse? Because I can't leave mouse behind because that's still very important to us. So that's just what we've done. Next, interesting. All right. I must have opened the wrong deck. Let me show you the right. So next, because those are JavaScript ones, so let me just go here and hide. I have a deck for JavaScript and a deck for C#. So the next level of APIs that we're going to have is these, what we call gesture APIs, right? And for gesture APIs, we have specific gestures at the system level that we want to recognize, and we want to make it very easy for you to code for them, right? So for example, the tap, double tap. Right, right tap or holding, where you hold, your finger for a few seconds and then you press. We have all of that in there, standard stuff. You're just going to subscribe to that event and you'll be okay. Like there's nothing exciting or hard about doing that. Gesture APIs are kind of basic. The thing about gestures is that when we are detecting gestures, we detect one gesture at a time. Right, so there's kind of limited, and so what we have, in extension to that, is this one thing that we call the manipulation API. And manipulation APIs are a little bit more interesting in that this is kind of like the accumulation of multiple gestures happening at once, and you have a little bit more control. So, for example, we give you multiple events, like rather than tell you, hey, that gesture happened and it's done, just handle it, like gesture, like tapped already happened. We give you kind of a manipulation starting event, a started event. Then we give you deltas as the event is happening, and then we give you a manipulation completed event. So you can control touch a little bit more, right? And that's what manipulation will let you do. It allows you to give, it gives you a little bit more control. And then what we do with manipulation is we actually transform, we take the input and we give you the transform already as it would have happened from the user. So we give you kind of a position or accumulate translation and accumulate rotation that you would have, right? So let me show you. It's much easier to explain it to you with a sample. So I have this sample right here, and it's just a few lines of code. So set a startup. So I have a sample, and it's nothing. It's just an empty rectangle here inside a canvas. So you see here, I created a canvas 600 by 600, and then I put a rectangle on it, and I put a transform as part of the rectangle, right? And then I subscribe to the manipulation delta event. So you see here, I'm just subscribing to manipulation delta. And a manipulation delta, I'm doing very little. All I'm doing is looking at the manipulation and saying, hey, what's the new transform that I should be applying to? Or what's the delta transform? So I'm just saying, look, there's a translation, so just add it to my previous translation, and that way the mouse, the rectangle is going to follow my mouse or my touch, my finger as I go. And I said I did rotation and I did scale, right? So you can see there, and I put a limit on scale so things wouldn't get too big if I did it. So all I did is handle manipulation delta. Here's me applying the rotation, and if I go here, you'll see that's the rectangle, and here's like me just moving it around. Now, if I go in there and I do, 2 fingers, for example, for scale and rotate, I can just come back here and scale things up and scale things down, and manipulation is giving me that level of control. A little bit more powerful than gestures, because gesture will be like, hold it, tap and hold, or double tap, or things that are a little bit simpler. So manipulation is a little bit in between, and it doesn't have to be something like pointer, where on pointers you can do the exact same thing, but you'll be listening to pointers and doing all that work to do the rotation and doing all that extra stuff. And that's it's impossible math, but it's math that will take you a day or two to write. So go ahead.
You mentioned that you can handle, maybe I misunderstood, one gesture at a time?
With gestures, with gestures it's usually one at a time.
Okay. So like sometimes in iOS, I'll use the analogy, is that you can assign 2 gesture recognizers for tap and a long tap, and then, or double tap, and then it can, if you don't get the double tap, then the fallback is you still get the tap. Yep. Or vice versa.
Yep.
Can you do stuff like that?
Yeah, so you can do the exact same thing. So when I say one at a time, what I mean is, you can subscribe to tap, double tap, and everything else. But what happens there is exactly what you're saying. Like, if somebody double taps, you don't get a tap event. You get a double tap, because, so that's what I meant by one gesture at a time. So you subscribe to all of them, right? You can say, hey, give me all the gestures, but the gestures are, not as cumulative. So I'm going to take 2 more questions, one of each, and then you guys can come up because I got to do the panel, and I just realized I'm 10 minutes over.
Okay, sorry.
Yep.
So, 2 quick questions. For manipulation delta, is that time or spatial?
I'm sorry?
The manipulation delta, is that time or spatial? Because you said it fires each time it moves, each delta it fires, right?
Yep. So the delta would be spatial.
Okay.
So it's not time, yeah.
Okay. And then the second quick question is, can Windows 8 handle multiple touch events between modalities, like you're pinching to zoom and you're also using the mouse to click on something?
So can Windows 8 handle input from 2 different devices in parallel? I'm hesitant to say yeah. I mean, my inclination is to tell you yes. But so I got 1 finger here, and but see, this is the paint app. So to the pointer API, that should be yes, but I cannot guarantee it. So let me go back, because see, the paint is looking at 1 finger. So I would have to get back to you a better answer, because I don't want to guess the wrong one. I'll take his, and then anybody that has a question, please come up to the front, because I want to make sure I get to the panel. I'm 10 minutes over already, and go ahead.
So this may actually end up being a longer answer that we need to chat about or needs to get covered elsewhere. In iOS,
there's different coordinate systems. You're in a view that's got its own coordinate system, et cetera, et cetera. So when you're dealing with gestures, you got to worry about all of that. Is the same true here, or are we out of that and just into and not worrying about it?
Yep. So they, I don't have to repeat the question. So no, we have one coordinate system. When you get into games, there's stuff there when you're writing games, DirectX and stuff like that. But in our world, we have one coordinate system, so we don't have. I know what you're talking about. We don't have that the way we do in iOS. So good. So lunch is ready. We will have a few people from panel. I got to go back and see who arrived because one of our panelists was coming from San Diego. Actually, two of them were coming from San Diego. And if you guys haven't heard, there was an earthquake there. So I haven't heard. Yesterday there was or two earthquakes there. So I got an email, but I haven't heard for the last hour and a half how things are coming. But lunch is next door. Feel free to, if you need to stretch your legs, feel free to take a break. Otherwise, we're going to have a panel here. We're going to answer any questions here, anything that you have from the day. And we have a Windows Phone person, because we got a lot of questions from phone yesterday. So we'll have a Windows Phone person be here in case you want to throw some out there. So go ahead.